for joining us today. Sean works at the Ecosystem Modeling and Integrated he works on ecosystem modeling and integrated ecosystem assessments as part of the Ecosystem Dynamics and Assessment branch. He's going to be telling us all about NOAA's integrated ecosystem assessment work. With that, I'll hand it over to Sean. Thank you.
Great. Thank you. And so just share my screen. PowerPoint. Okay, are you seeing my screen?
Looks great. See the draft form so far.
Yeah. All right. Are you seeing notes or are you seeing the actual presentation?
I've seen the presentations. So far, your notes are.
Notes.
Oh, you're seeing the notes?
I'm just seeing the kind of. I'm seeing the main slide and the sub slide. So if you hit presenter view, we should see them.
Okay, I'm in presenter mode, but so you're seeing two slides, not just one. Is what you're saying?
Yeah, I'm seeing your main slide, and off to the left is the smaller.
Okay.
Several slides. Yeah.
Selecting the share screen, just make sure that the window you've selected is the presenter view.
Now what do you see?
Same thing.
Same thing? Oh.
You might want to unshare and share again. That sometimes does.
Okay. All right. Maybe I'll just do my entire screen and that might work. Oh, but I closed my presentation down. Great. Okay. What do you got now?
That looks great.
You did it. Perfect.
Okay. I apologize for that. Yeah, so I'm going to be talking about integrated ecosystem assessments, as Fiona mentioned. And I'll start off by giving you a flavor of what an IEA is, and then give a couple examples of how we've applied it here in the Northeast. And then also an example from the Gulf of Mexico, which I think is going to be more similar to how we would apply one for offshore wind. And I just want to note that my name's the only one on the title slide here, but obviously it's a work of a lot of different folks from across the Northeast Fisheries Science Center and also a lot of other institutions as well. So there we go. Okay. So I'm going to start with some background on the IEA. So much of the work that's done across the country here is coordinated by the NOAA IEA program. And so this is a NOAA-wide program. So it's across the various line offices that we have, including the National Marine Fisheries, which I work for, but also the Weather Service, the Ocean Service, the Office of Ocean and Atmospheric Research. So all the different parts of NOAA are actually involved here. Although it's led out by the National Marine Fisheries Office of Science and Technology. We have 5 active regions right now working on IAAs, as you can see in this image here. And what we do as a program is try to apply the IEA approach, which is a science-based process for conducting ecosystem-based management. And the process provides decision support information in an ecosystem context by integrating all components of the system, including humans, into the decision-making process that way managers can balance trade-offs and determine what is more likely to achieve their desired goals. The important thing is that this process is scalable, collaborative, and adaptable, which means we can integrate information from multiple partners to provide the synthesis of an entire large marine ecosystem, or something as fine scale as the offshore wind development that we've been talking about the last few meetings. I'm sure some of you have seen some iteration of this figure before, but I just wanted to highlight what we're talking about when we go into ecosystem-based management. As a federal scientist, we sort of love our acronyms. So there's a bunch of different ones that are very similar and very confusing. So, when we think about traditional fisheries management, a lot of times you're down here in the single species realm, but you may have some assessments that think about climate, habitat, or the predators. But much of the work that I've been involved in and a lot of my colleagues do is more up in these EAFM and EBFM. And so there's some nuances, differences between those. The ecosystem approach to fisheries is still staying closer to the single species world, but explicitly taking into consideration some of these other factors. EBFM, ecosystem-based fisheries management, That's where you're sort of more of a place-based management sector, where you're managing things more in aggregate than in individual species. But what we're really talking about is EBM, where we're sort of dropping the F and going to ecosystem-based management, where fisheries is just one part of the whole picture. And now we're going to be trying to integrate in with, offshore wind development. And this is really where IEAs were meant to operate, is sort of this intersection or cross section between the EBFM and EBM world. And that's sort of what these wavy lines represent in this figure as well, is that there's sort of a blurred, there isn't like a hard delineation between some of these things. So this is the world we'll be operating in with the integrated ecosystem assessments. And so this is the IEA process. And so you'll notice there's 5 major steps in this process. And the first one being starting with defining your goals and your targets. And some people call this scoping. And this is really an important step to take, because the process is very adaptable, and you can iterate through a bunch of different ways, but it's really only as good as what your initial scoping and your goals and targets are. The second step then is to identify, select, and if necessary, even develop new indicators. And what these indicators are is to give you a representation of what the status and trend of a particular component of the system is that you're interested in, and how it can help you support your management decisions. Then your third step here, which is sort of where the whole process gets its name from, is to assess the ecosystem. A lot of times this is done by developing some sort of a status report where all the indicators are looked at collectively and sort of synthesized across as appropriate. And then the fourth step is to analyze uncertainty and risk. And here you want to figure out what your probability is of an undesirable outcome to management. And you can do this a number of different ways, and whether it's a qualitative or a quantitative model to address the risk. And generally you want to see how susceptible the system is to any human actions or natural variation in the system. And then the final step is to apply some sort of management, some sort of decision support tool. So we sort of label it here. Well, it's not really labeled here, but a lot of times this is thought of as management strategy evaluations, but it really could be a number of different flavors of decision support tools. And then the other sort of takeaway here is this process is deliberately shown here as a loop because it is an iterative process, and so you can at any point sort of loop through and go back to the various parts. And even if you get all the way through the system, or all the way through the process rather, you can then go back and either refine your targets or develop new indicators if you didn't see something. So once again, adaptable and iterative is really the take-home message here. So I've given you an idea of what an IEA is, and so now I'm going to talk quickly about a couple of examples. So the first is really from here in the Northeast, involving a bunch of work that we've done with the Mid-Atlantic Fisheries Management Council. So several years ago, the council did their own sort of scoping exercise and reached out to a bunch of fishermen and other stakeholders to really gauge what their interests are, or what they could do better, and what they wanted to do moving forward. One of the things that ended up being identified was that they wanted to take a look into ecosystem-based management, or they actually have decided to go with an ecosystem approach to fisheries management, which you might recall from that previous figure was sort of that second tier, where you're still sort of managing things at a single species level, but taking explicit account into other factors in the environment. And so they developed their policy document in 2016 of how they wanted to do that. And so if we go over here, go over here to, this is from their document. So you see that they want to prioritize what's going on, develop a risk assessment, and figure out what the highest risks are within their system, So what parts are linked to the most risk, or what do they not know the most about in their system? Refine that, develop a conceptual model, figure out what questions they can answer, what information is needed, and then analyze using that conceptual model through a management strategy evaluation to determine what is the best strategies, which strategies perform best, which strategies are the most robust to various environmental forcings, and then implement and monitor and go all around. And so they developed this sort of on their own, but if I think if you don't need to squint too hard to realize that this looks a lot like the IEA loop, and because it basically is the same kind of thing that you would do in an IEA loop. And so right about the same time that they were doing this, we were developing our state of the ecosystem reports. And so these are reports that hopefully many of you have seen. They're relatively short, about 30 pages. We're trying to keep them not technical, but rigorous. And so they're meant really to inform the management councils. And the focus really was to provide a synthesis across a broad suite of indicators and give the councils a big picture ecosystem context that they're making their decisions within. And throughout this report, we tried to make as many linkages clear as we could from indicators directly to management objectives, using the existing legislation to derive what those objectives are. And we actually create two of these reports, one for the Mid-Atlantic and then one for the New England Council, which we break into our various ecological production units. One for the Mid-Atlantic Bight, and then 2 EPUs for the New England report. And the Mid-Atlantic took that information, and then they decided to develop their risk assessment. And the way they did that was they predefined risk criteria based on the indicator status and trend. And so I'll just give you an example here using commercial revenue. So they took a look, and you could think of, let me go on forward. You can take a look. This is the time series of total revenue in the region. And so you can take a look at the long-term trend and also sort of a short-term trend. So you can see this green shaded area here being the last 10 years. This black line is actually the total revenue from everything that's landed in the region, and then this red line is the managed species for the Mid-Atlantic. And so what you can see is that there's really no short-term trend that's different than the long-term trend, which is this purple line, which shows a decreasing trend over time. And so if you go back to what their definitions are here in this table, they decided to put it in as a significant long-term revenue decrease. So the risk came in as moderate high. And so you can imagine that you do this for all the different various suites of indicators that we have, and they can develop a table similar to this. And this is only part of the table. And there's a couple different ways you could look at this table. You could sort of go across from a species and see what had some of your biggest threats, or you could go down a column and say, well, maybe we really need to start taking a look at, for example, here, allocation has a lot of highest risk elements to it. And so the council took a look at this and decided that they really wanted to take a look at summer flounder, which was associated with most of the risk, or a decent amount of risk that they found in their system. And so they convened a working group which developed a conceptual model and came up with some draft questions that the council could decide to pursue. And this is now proceeding on from the conceptual modeling to management strategy evaluation. And so here you can see actually the conceptual model. It's probably a little hard for you guys to make out in on your screens here. And this is the final question that they came up with, is evaluating the biological and economic benefits of minimizing summer flounder discards and converting discards into landings in the recreational sector, and that they needed to identify management strategies to effectively realize these benefits. And they selected this question for a number of different reasons. I've listed them here, but mostly because it's sort of aligned with a lot of their traditional management process and was important to stakeholders and linked across several different parts of their management system. So you can see here the discards links up to seafood production, fisheries distribution, recruitment and distributional shifts and growth. So there's a number of different things here within the conceptual model that it linked to. And so that's what they decided to work on. With the next step being to conduct a management strategy evaluation, which is a way to address various forms of uncertainty and address trade-offs in the system. And it has an operating model and a management procedure. And I realize that I'm already hitting my 15 minutes here. So I'm going to fly a little bit through the next example. So this is a much smaller scale example, but I think one that's going to be more relevant to the offshore wind development. So here down in the Mississippi, in the Gulf of Mexico, they have this project called the Mid-Barataria Sediment Diversion. And basically, it's a project to divert the sediment and fresh water from the Mississippi River to rebuild freshwater wetlands. Because due to all of the human development in the area, they've blocked off a lot of the natural sort of sediment deposit things, and so you can see here on this figure on the bottom left, quite a rapid decline in a land area in the Mississippi Delta down in there. And so they're using this to develop an ecosystem status report and embedding in that, of course, the scoping process, the development of calculation of indicators and synthesis of indicators. And this, I think, is where we'll be going with the offshore wind development, that will have to have some sort of a participatory modeling and scoping. And so they interacted with local subject matters and stakeholders, had a series of iterative individual meetings, and then sort of group workshops over the course of several years, including social scientists, from various NGOs, academics, Sea Grant, and developed as many indicators as they could and put it into this larger conceptual model here. And this is similar to the conceptual model that was developed in the Northeast, except it's not in a circular fashion, so it's a little bit easier, I think, to see. But you have sort of your ecological components, but then you also have social components and biophysical components. And if you drew all the lines, it make it kind of a little difficult to see. And then they took that and tried to identify, what indicators work with all those different components of the system. There's obviously some that have multiple sort of proxies, indicators that lead to something. So you can see for water quality, you might be looking at salinity, temperature, chlorophyll A, et cetera. And so that's where they're at with that. And so the summary here is that they were able to, co-produce social ecological indicators. They're developing the report that's going to have drivers, pressure, states, and then synthesize long-term data and figure out what data they need. And they're doing it at a point where they will have baseline conditions before a large-scale restoration, which will be, important for monitoring and assessment and adaptive management of other restoration projects as well. And I think is really key to, helping out with some of these draft EIS statements and the cumulative impacts that we just heard talk about. So this is like my last slide, and I apologize, I didn't quite get it to 15 minutes, but so the integrated ecosystem assessment provides a framework that can help conduct ecosystem-based management, and it is designed to be collaborative and iterative. So I think it's perfect to try and work with all our various partners in the region and do what we can to get this right. And so right now in the region, the majority of the work that we've done has been in collaboration with our fishery management councils, but the IEA framework is scalable, and we've seen in other parts of the country. The Gulf of Mexico is an excellent example that I sort of flew through, but then we also have in the Pacific Islands, they have a West Hawaii IEA that is just looking at one of the coasts of one of their islands. So it's definitely scalable, and I think we can work for these wind farms.
Great.
So with that, and there's a long list of people that have contributed. I also especially want to thank Sarah and Shannon for giving me some of these slides. And if you have more information, if you want to dig in deeper to what the integrated ecosystem assessment program is, you can go to that website.
Great, Sean, thank you. I'm going to try and get in a squeeze a few questions before break. So one,
Yeah.
how long does an IEA take to get started, and what is the effort to maintain it?
Yeah, that's a good question. I mean, they can be quite time consuming. I mean, the work that we've been doing now with the management councils is actually we produce those reports on an annual basis. So we have at this point sort of developed the infrastructure to getting the indicators into the report. We've automated as much of that process as we can. And so we're able to produce 2 of those state of the ecosystem reports every year. And we see similar things in other parts of the country, other regions where they've been doing this for a while. So the initial sort of status reports can sometimes take a couple of years, just pulling together the indicators and everything else. I think we have a little bit of a head start on that here, in that, our social science branch has already been sort of looking at some of the fishing information that goes, obviously they, based on the last presentation, there's been a head start on the EIS and the draft EIS. And so I think it would probably take us at least a full year to really spin up and have some kind of a status report. And then obviously if we want to do any kind of participatory work in the world we live in right now is going to be difficult, but we could try and pull that together.
Great, thank you. Maybe 1 or 2 more questions. And partly you answered that through the last example, but there's a 2-part question here. How do we go about identifying and vetting indicators for fisheries in the context of offshore wind? And what are the criteria of a good indicator?
Yeah. So there's been a lot of work on sort of indicator selection. And, you could go into a whole 20-minute or longer presentation on developing smart indicators that I can't remember what the whole acronym stands for, but basically you want things that are measurable, that are timely. So you want an indicator that is reacting to changes in the system. So if you have a relatively stable indicator, that might not be as helpful as something that is reacting to perturbations in the system. Not to say that you want something that's varying widely all the time. And so you want to make sure that it is addressing sort of the component of need that you're interested in. I think I only answered the second half though. What was the first half of the question again?
It's really how to involve, stakeholders and others in developing.
Oh, yeah. Yeah, and I think a lot of that is really, local ecological knowledge kind of things, like getting in a room and drawing out the conceptual models. What I didn't show here was it was part of our State of the Ecosystem report is that we actually have a conceptual model of how all the things in the system work, and we put that together over the course of several months and really with work between local subject expert matters for social sciences, for ecological sciences, for physical sciences, and we could easily you sort of start there, but we have examples of participatory modeling where we can sit down and have the fishermen or other stakeholders draw what their idea of the system is as well, and then we can work together and grow from there.
Great, Sean, thank you. These are some other great questions we're not going to have time for. They're great. And as I noted in the chat, all the Menti questions are being saved. We'll